All right, let's take a look at page 40, converting percents, decimals, and fractions. So we've talked about decimals and fractions already. Percent is just a ratio of a number to 100. Per cent means per 100, cent like a century or the number of cents in a dollar. Or how many out of 100. There are 3 ways that we can write these: percents, decimals, and fractions. So there are 6 ways to convert from percents to fractions, from percents to decimals, and so on. So let's start with percents to fractions. We're going to put the percent over 100 and simplify. So 24%, we have 24 over 100. I noticed that 4 goes into both of those. Could have done 2 twice, but I'll take out the 4. It's a little faster. I get 6 25ths. 6 and 25 are relatively prime. So there's my answer. 24% is the same as 6 25ths. For percents to decimals, we have a couple ways we can do that. We can either divide the decimal by 100 or move the decimal left 2 places. So 105 divided by 100. We could do long division, or we could just use our calculator. We get 1.05. And 105, if I scoot that decimal point over 2 places to the left, that takes me to 1.05. I do want to see your work one way or the other. I don't care if you show me the little arrows or if you show me 105 divided by 100, but I do want to see your work there. Decimals to percent, so going backwards from what we just did. Well, let's do the opposite operation. Let's multiply the decimal by 100, or we can move the decimal right 2 places. So 0.031 times 100 equals, let's see, 3.1. And similarly, 0.031, and this is actually how I did the division. I didn't do this part in my head. I kind of used this little trick. And I get, oops, don't need the 0 anymore because zeros at the front of a number aren't important unless we have, for example, a 0 to the left of the decimal place or zeros to the right of the decimal place. But I don't need to write this as 0.003.1. Decimals to fractions. We're going to write the fraction as you would read the decimal. Remember, we learned about how we don't just call it 7.5, it's 7 5/10. This is why. Write the fraction as you'd read the decimal, then simplify. 0.4, I read that as 4/10. So this is 4/10. I fixed the tenths because it was in the last digit is in the tenths place. Could have been the hundredths or the thousandths if I had more decimals or more digits over here. And 4 out of 10, well, 2 goes into both of those. 2/5. Fractions to decimals. So going the reverse of what we just did. This one is nice and simple. We're just going to divide the numerator by the denominator. We can do that with long division or with a calculator. 7 divided by 2. Again, I want you to show me your work. On all of these, show me your work. So 7 divided by 2 can be your work. You type that into the calculator or you do it long division. You get 3.5 or 3 5/10. And fractions to percents. We want to convert the fraction to a decimal first. So do what we just did. And then we want to take the decimal and multiply it by 100. It's always that 100. factor, whether you're multiplying or dividing. Or you can move the decimal right 2 places. So this is some extra work. We have to convert the fraction to a decimal. We have to do everything we did up here, and then we have to convert the decimal to a percent. So basically this is doing this first and this second. We can do that though. 5/27. Well, 5 divided by 27, that is not a nice number. It's going to be about 0.18. Let's see here. Yeah, 0.185. And the 185 is repeating. So it's 0.185, 185, 185, 185, 185. We've written it as a decimal. We had to use a repeating bar. That's okay. Now we want to multiply the decimal by 100, or I think it's easier, just move the decimal right 2 places. So I'm going to take my decimal point and move it here. But that looks a little confusing because I can't just write 1. I cannot write it like this. Repeating bars only make sense after a decimal point. So what can I do? Well, I can take this and write it out as 185, 185, 185, dot, dot, dot. Now I have 18.518518518, dot, dot, dot. And we'll notice that now it's 18.518 with a repeating bar over the 518. So even though it started out as a 0.185, it changed to a 518, not because the numbers magically rearranged themselves, but because we rearranged where the decimal point was. And the decimal point is kind of the key to telling us which part of it we can write as repeating and which part we cannot. Okay, so fractions to percents, that one is basically turn it to a decimal and then turn the decimal to a percent. This one was a little harder than most because we had that repeating decimal. If we had done something a little simpler, like 5 divided by 25, that would have been easier. And just for completion, let's do that. 5/25. Well, 5 divided by 25 is 0.2. I'm going to move my decimal point over 2 places. I don't even really have anything over there, but I can always put a 0 at the end after a decimal. So this becomes 20%. Excuse me, I forgot my percent sign here. And notice that 5 divided by 27 is a little less than 5 divided by 25. 18 and change is a little less than 20. So we're pretty confident about our answers. Okay, let's go through a few of these examples. So let's start with number 1, 36% as a simplified fraction or mixed number and as a decimal. All of these are writing them as 2 different ways. They all have this and that. So 36% is a simplified fraction. Well, I take my percent, I want to write that as a fraction. Remember, that's 36 over 100. Let's simplify it. What goes into both of those? I'll give you a moment to think about it while I get the red pen. And you might have seen 2, 4 also works. Either way, if you do 2, you have to take out another 2, but that's okay. We get 9/25. We wrote it as a fraction or mixed number. It's simplified. 9 and 25 are relatively prime. And we also want to write it as a decimal. We can either go from the percent to a decimal or the fraction to a decimal. I'm going to go from the percent to a decimal. I find that a little easier. So I'm going to take 36%, which has a decimal point at the end, because anytime we have a number that doesn't have a decimal point written, It just goes at the end. And I scoot this, think about which way. Do I want this to be 0.36 or 3,600, 3,600? Well, 36% is less than 1, right? 36% is less than a whole, it's less than 100%. Definitely want to move it this way. And so my answer is going to be 0.36. I like that 0 before the decimal point, because if I just write 0.36, it can be hard to see that decimal point. If you look in the thumbnail, I'm guessing you probably can't even see it. Maybe you can. But 0.36, and I do try to make my decimal points really big so that they can be seen easily as well. Okay, decimals do not need to be simplified like a fraction would. They're just what they are. So number 2, we're taking a decimal, writing it as a percent, and a fraction. Number 3, we're taking another percent. This one's a little tricky because it's a smaller percent. It's 5.6%. But that's okay. It's very similar to this. Just think about 5.6%. I'll get you started on it. That's 5.6 per 100. And here's what I would do at this point. I would say, I don't want to deal with a fraction with a decimal in it. What if I multiplied top and bottom by 10? I can do that. We talked about fractions, how we can multiply by the same thing, top and bottom. And then I get 56 over 1,000. I get a whole number over a whole number. You take it from there. I'll do one more with you though. How about 7/12? So 7/12, I want to write that as a decimal. 7 divided by 12 is 0.683 repeating? No, 583 repeating. Okay. 0.583 repeating. Notice that the repeating bar is only over the 3. This is 0.58333333, not 0.583583583. So that repeating bar is important. This is 0.58 with 3 repeating. And we can also take it as a decimal. Scoop the decimal point over 2 places to make a percent. And we get 58.3%. I'll be honest, I do not memorize the rules for the decimal to percent means move the decimal point this way. I just kind of think about it each time. You're welcome to memorize the rules if you want, but I just remember that the percent looks bigger than the decimal. 100% is equal to 1.0. So if I have 58%, that's going to be less than 1. It's going to be 0.583 repeating. It's not going to be, almost 6,000. So I know I have to move the decimal point 2 places, and I just logic through which way I want to move it. Let's take a look at page 41. As always, you may finish this, pause and finish this now, or finish it later. And let's look at solving percent problems. We've got 3 quantities to work with. The percent, the amount, and the base. So if we have 30 as 20% of what number? I like to start with the percent because usually it has the percent sign. So it's really easy to identify. There's my percent. Now the amount and the base are a little bit trickier, but not too bad. The base is what you start with. And the amount is what you end with. Let's see if we can go ahead and write these in. So start, end. So 30 is 20% of what number? That means 30 is, even though I say it first, 30 is what I end with. I could say 20% of this number is 30. The answer is 30. 30 is the answer. 30 is 20% of whatever number we're looking for. So 30 is the base. 30 is the amount. I just said that, what I was trying to. 30 is the amount. And then the base is of what number? We don't even know. So the base is the unknown in this case. So we have, oops, let's go ahead and jot these down a little more clearly. So we have the percent, that's the number with the percent sign, which in this particular case is 20%. The base is the original amount, or the whole amount. And that is, in this case, the unknown. We don't know what we started with. And then the amount is the amount that is based on the percent. It's the result, the answer, the end. One tip that I use is base often has of attached to it, not always. It is not a guarantee. But when I see of what number, my brain thinks, okay, that what number is probably the base. Not always, but it often helps. So let's look at the formula. What we're going to do is we're going to say that the percent as a decimal. So a good thing we learned how to convert. The percent as a decimal times the base equals the amount. So P times B equals A. I sort of remember it as peanut butter or lead, I suppose. Either way, percent times base gives you the amount. The amount is the answer. So if we were asked to write an equation that represents the following problem, we're going to start by labeling our percent, our base, and our amount. So again, I start with percent. I see 22% because it has a percent sign. I'm done with that part. Now I just have to figure out the base and the amount. I see the of, so I'm thinking that's probably the base. And is this indeed what I start with? I start with some number, I take 22% of it, I get 50 as my answer? Yes. So this is the base, and this is the amount. Now I have an equation. So P times B equals A, but first I have to turn that P into a decimal, 22%. I'm going to use the turning the decimal point. Remember, if there is no decimal point in a number, well, it really is there. We just don't need to write it all the time. Here we do, so we'll write that as 0.22. So percent as a decimal times the base, which I don't know, equals the amount, 50. Okay? So I want to know what the base is. What I'm going to do is I'm going to divide by this coefficient here. I'm going to divide by the thing that's getting in my way. So if I take this, divide by 0.22, divide by 0.22, I get B equals 227.27 with the 27 repeating, not just the 7, but the 27 repeats. So there's my base. There's my answer. Kind of a messy one, but it works. Let's see. So number 2, again, we're identifying percent, base, and unknown. So you'll write a P, a B, and an A. Look at these 2 numbers. First thing I notice is there's no percent sign. So that gives me a hint as to what my unknown is probably going to be. Number 3 is similar. We have 110% of 24. So remember, 110%, that's over 100%. That's okay. I can still write that as a decimal. It's just a decimal that's a little bigger than 1. We can handle that. Let's take a look at page 42. So we've got 15% off a purchase of $100 or more. The guitar has a $220 price tag. How much will it take off the $220 original price? There are a lot of numbers in there. Normally we have two of these, the percent and the base, the percent and the amount and the base. Here we have three numbers, 15%, 100, and 220, which is written in there twice. I don't need all of these numbers. One of these numbers is neither the percent, the base, nor the amount. One of these numbers is just a piece of information that tells you if the coupon can be applied. So figure out which piece of information you do not need, and then you can write your percent, your base, and your amount, and figure out how much that coupon takes off. Notice it's asking how much money the coupon takes off. It's not asking how much money the guitar is at the end of it. So those would be two different questions. Number 5, we're buying a calculator, and we're asking two questions. What will the tax be, and what will the total be? You can solve these two problems independently, or you can solve this problem and use that to solve the total problem. Number 6, we're buying some books at a bookstore, and this bill includes 5% sales tax. So how much were they originally? When you're done with your answer, make sure that it's less than $31.50, right? Because if $31.50 includes the tax, the books should cost a little less than $31.50. Number 7, we're working 20 hours 1 week, and 3 weeks later she works 36 hours. We want to know by what percent her hours increased. So we've got 20 hours, we've got 3 weeks later, we've got 36 hours. Again, we have three numbers. One of these is not needed. One of these is irrelevant. 20 hours at her job, 36 hours, those are important, but 3 weeks later, I don't care. It could have been next week, it could have been last week. This part does not affect the problem. So now we have our two values, and we're going to think about what percent her work hours increased. Okay, so let's figure out how much her work hours increased before we even figure out the percent. The increase, just the raw increase, the raw change, is 36 hours minus 20 hours. We get 16 hours. That is the amount of increase. That is the amount of increase. That is the base. I apologize. That is not the base. It took me a second. Okay. Why is that not the base? Pause it. Think about it for yourself. I make mistakes too. Why is it not the base? So I said an increase of 16 hours. I said that often means base. I told you it wasn't an absolute though. 16 hours is the amount that it increased, right? This is the change. 20 hours is what she started out with. This is the original amount. This is the base. So sometimes it's easier to start with one than the other. I found it easier to start with the 20 hours and say that's the base. The 16 hours, well, it certainly can't be the percent. That's the amount. That's how much it went up. And my percent is my unknown. So percent times base equals amount. Could have that multiplication dot in there, don't need it. Percent times 20 hours equals 16 hours. Don't really need those parentheses either. Divide both of these by 20 hours. Notice that I'm keeping my unit of hours. They're going to cancel out, which is good because percents don't have units of hours. And I get 16 over 20. So P equals 16 over 20. I can simplify that first, or I could even multiply top and bottom by 5, I noticed, to get 100 on the bottom. Or I could convert this to a decimal and then convert it to a percent. I have lots of options. I'm going to use that little trick that I mentioned. Times 5 times 5. P is 80 over 100, which is 80%. If you're not a fan of that method, that's totally fine. Take 16/20ths, divide it on your calculator. You'll get 0.80. Remember to move that decimal point back over 2 places to get 80%. Finally, we have Jose, who is getting paid a little bit extra, or a lot extra. We want to know how much he's paid on a regular day. And when you're done with those, I also want you to take a look at the worksheets, pages 91 and 92. I'll meet you in the next video.